Okay, what I want to talk about now are different cloud service models. And this is going to be a little bit of a preview for the rest of this section 3. It's like a roadmap for what we'll be doing. One of the things that the cloud allows you is to have this flexible service model and flexible management model. You have a playground in the cloud to do just about any kinds of computation that you would like. And the cloud providers, it's up to them to support the management style you prefer as a developer. And if the cloud provider is smart, they're going to give you as many different tools to do your job the way you want to do your job. And so this is where some of the complexity of the cloud has shown up. Like if you go to the AWS console and you bring it up and you see like 100 different services, the reason why there are 100 different services is because every time someone creates a cloud project, they're going to want a different subset of the services that AWS provides. And it's AWS's business model to provide every kind of service model so that they can get more customers using their platform. So before AWS and Google, though, you basically had one model and only one model. And so the model was you purchase everything. The building, the hardware, the routers, you build all of that stuff manually. And then anytime you have a spike in usage, you have to go and buy the machines and deploy those. And you have to manually manage things like data backups. And then you're also going to have to manually implement any authentication your application needs, all of the data analytics that your application needs. That was the one and only way of doing things before the cloud. You're rolling your own of everything. The cloud, you get a choice. The cloud gives you this choice. If you actually want to do all of this stuff manually, the cloud is happy to just give you a bunch of servers and you go crazy. You do your custom thing. You build everything out manually. And it's more than happy to have you do everything. And this is basically pretending that the cloud doesn't even exist. There are no cloud services to take advantage of. It's just a bunch of machines. So that's one way of using the cloud. You can have a different way where you're trying to leverage some of the automation that the cloud provides you. So for example, if you're doing DevOps and you have this continuous integration, continuous deployment pipeline, and you want to do some automated testing, you want the cloud to be able to, like, if I just click this button, I want you to run all those tests. I want you to bring up all the infrastructure to run all those tests and then bring it down when it's done. This is where the client is doing some management of the resources, but the cloud is doing everything else. If you don't even want this, you could go to this NoOps, this fully managed model, where you don't even have access to the resources. You're basically doing what Snapchat is doing. You're just deploying an app. Okay? So you have this choice. And a lot of companies, if you're unlucky, are doing this. And you work for a company that's doing this, you're basically stuck doing the first half of this course. Maybe you score a job at a really visionary place that's trying to do this, and you're focused more on the apps. But more likely than not, you're probably doing something in between, because a lot of people are trying to shift their app, their legacy app, into something that's more fully managed. So this is where you would basically want to know the whole stack right now because of this. Okay, so you prefer none. If you don't have to learn this stuff, you don't want to, especially if someone has abstracted it out. It's just like you could learn socket programming if you wanted to, but I wouldn't recommend it. Okay, so this mirrors the offerings on Google Cloud. And you can get this exact same sort of span in AWS, but this is a picture that I like from Google Cloud. This is a breakdown in terms of the level of abstraction and control across their offerings. So all the way on the left, the client does everything. It's minimally managed. You bring up the servers, the virtual machines, you configure them, you do the logging, you do the analytics, you do the management of those VMs, you bring them up and down yourself. So that's all the way on the left, which is basically what you've been doing with some of your code labs, and which you will be doing in the subsequent ones. And you deploy your DevOps pipeline on a compute engine instance, and then you're managing that directly. And then if you go all the way to the right, you're going to do something that's highly managed, where you don't get your hands on a virtual machine. You don't even know what machine all of this stuff is running on. And so this is the sort of the span, the range at which your code labs are going to be. So you're going to do code labs in each one of these areas. Okay. So we're going to first start with infrastructure as a service. This is the simplest model, and this is where the cloud started. It's just, this is hardware as a service. This is AWS saying, I have all these servers from Christmas that aren't running. You can rent these servers out for me, and I'll give you a virtual machine on them and an IP address, and you go crazy. This is infrastructure as a service. All of the functions of the server and the software is managed by the developer or the company that's renting these servers. So the logging, the operating system, the libraries, all of that stuff is handled by whoever is deploying it. And so these are examples. So Compute Engine, EC2 is the Amazon one, and Azure's virtual machines. So this ended up being, if you have hundreds of virtual machines and you don't want to manage all of those, if you don't want to be the person managing hundreds of virtual machines, you end up looking for ways to automate this. And so how do you manage these deployments? This is where all these companies, Chef, Puppet, Ansible, Terraform, this is where a lot of automation companies in the cloud space started to develop so that they could actually deploy these virtual machines programmatically. Okay, we'll revisit that later on in this course. Another thing you can do is the exact same thing, but with containers. So rather than specify virtual machines, this is what Google wants you to do, just specify a container image, and then we'll run that up and down. You can deploy those manually. And often these containers are mapped to the actual virtual machines that are running them using an infrastructure as a service. And so what you would do is you would deploy all these containers, and then you would have some kind of orchestration runtime to keep the containers running. So if a container crashes, you want some monitor to say, hey, that container's not responding anymore. I'm going to go in there and restart the container. And so this is what these services are doing. Amazon Elastic Container Service, things like Kubernetes, and then the Azure Container Service. This is what they're doing. They're trying to manage your containers in a way that they're always up. They're always the way you expect them to be, always running. One issue with these container services is that they're typically always running at least one copy. Like there's always a container running on some virtual machine, and then you would elastically scale up from there. You would like for the thing to cost $0 if the thing is not being used. And this motivates serverless computing. So this is on the far end of the spectrum. So I define serverless computing, and a lot of people do, as a solution that costs nothing if nobody is using it. No upfront provisioning, no management of servers, pay for what you use, and you can go down to 0 servers and then wake up when needed. So that is my definition of serverless computing. The model is that the developer produces code for the application, and then the runner, the cloud provider, is just going to automatically bring up the infrastructure to run the application. And the developer doesn't get to see the machines or the networks that are actually running the app. Okay? So the analogy is like infrastructure as a service is like a stick shift, a manual stick shift for a car, and then serverless is like an automatic. Okay. So there are many incarnations of serverless. There's serverless this, that, and the other. Here is a breakdown of all the different serverless things that we're going to do in this class. There are serverless containers, and this is what Cloud Run is. There are serverless platforms, that's what App Engine is. Serverless functions, Cloud Functions. Serverless backends and applications, that's Firebase. We're going to use serverless cloud storage and serverless databases. So this you've already used in your SQL lab, the cloud storage service. This is what you're going to be using for your homework, and then at the very end of this class, we'll be using serverless BigQuery. So this is the other end. So this is sort of the compute, sort of infrastructure as a service end, and then all of this stuff on the other side is serverless. Okay, so just to give you a brief rundown, serverless containers, the user supplies a container image. So you have a container image now, or you will at the end of this week, and you say, okay, here's my container image, here's my link at Docker Hub. I want to deploy this, and you basically instantiate this container when anyone hits an endpoint. So if anyone hits your container website, like your Hello Ubuntu port 80, the runner, Cloud Run, is going to automatically bring up your container and process that request, even if your container wasn't running initially. It will pull it, run it, and then process that request, hopefully very quickly, hopefully within a couple seconds. Now, the very first time it gets there, because it's having to pull your image and then start it, it might take maybe 5 seconds. That's called the cold start of a serverless implementation. But then eventually, if you're getting a lot of requests, the subsequent request will be very quick. The real advantage of serverless containers is that you just supply the container. You don't have to think about the machines, and there's no vendor lock-in, right? Like I can run a container. The container is the portability layer. So then if I do this, and then AWS has a serverless container facility. They don't right now. But if they did, I could just say, oh, I'll run it on their service because they're cheaper. Then it's a market rate pricing of this particular facility. Okay. But there is some issue here, is that the runtime, Cloud Run, is controlling how your container scales up and down. So if it gets 10 requests in a second and decides to launch 50 containers to process it and then charge you for it, you're stuck with that. Well, you're not stuck with it. You can do some configuration so it's not too exorbitant. But like some people actually want control over how the infrastructure is spun up and down for their application. Maybe they always want a minimum of 1 container always running. And so these kinds of services don't give you a lot of flexibility, which is what this thing is talking about. Okay. You could also have serverless platforms. And the idea here, it's a very similar idea to serverless containers. This is called, otherwise known as platform as a service. And in this model, the cloud provides you a development environment. And it's more like a one-size-fits-all development environment. And this is the way it's run is it's got these predefined containers. And by having predefined containers, it makes their implementation much more efficient. Yes? Oh, that was me just exaggerating. Like, hey, if Google wants to make money off of you, it could just say, hey, you got 10 requests, I'm going to launch 50 containers and then bill you for it. I'm just being cynical. Like, Google wouldn't do that. But like, the idea is that you don't know how it's going to scale up or down based on demand. Well, like you would need like thousands of requests per second for you to start a second container. Because most web servers, you can do thousands of, well, it depends on what you're doing with the request, but if it's a static site, if you're just serving files, for example, you can do thousands of those per second. It's only if, so you remember your CDN lab where you had to place the thing under siege? That thing was doing thousands of requests per second in order to drive up the load on the virtual machine to spawn another one. It's the same idea. There is some algorithm that's going to control how the thing scales up and down. Now, initially, if you don't have the expertise to manage that algorithm, you would just say, you know what, whatever the default is on this platform as a service or containers, I'll just use that. But you'll see if companies are really trying to optimize their sites and the amount of burn that they're spending on the cloud, they might want to tweak exactly how much to spend on each one of these things. And then you would have to go away from something like Cloud Run. Because Cloud Run, it has a pre-programmed way. They don't give you a choice. And in a way, that's beneficial, right? Like if there's too many choices here, the complexity is hard to manage. And so this is typically done. You'll have a couple labs that use this. If you have a simple sort of function and you just want to, that might not be very popular, maybe you'll just do a serverless container and then just go with that. So the other thing is this platform as a service. So the idea here is that maybe I am going to restrict the runtime environment, and I would restrict it because if I do serverless containers, everybody's bringing a different container to my platform. I gotta keep a gazillion copies of these containers running on all these different VMs that I'm gonna run these containers on. And so what App Engine, you'll see that this is more expensive. So if you are willing, if you're not gonna run anything too custom or too crazy, then what you could do is in App Engine, they have these predefined containers. There's like a standard App Engine, and then there's a Flex App Engine. And the idea here is to try and restrict your runtimes so that they don't have to store all of these container image layers on their platform. So that's the idea of platform as a service. So you provide some restricted development environment, these predefined containers, and then your app doesn't know about containers. It's just an app. Just making calls in, for example, Python or JavaScript. You don't have to build a container. The container gets built for you. You do the Python app, and then it automatically scales the containers up and down based on your application usage. And so here you supply the app, and then both the machines and the container are abstracted out. You don't see them underneath. Okay.
So container, if you were programming multiple containers, you'd have them all call into like the same database. You'd want them to share a database or something. Is that the idea?
So typically for containers, you want them stateless. So I had you build a container with SQLite. That's state. You typically would never do that. So let me say up front, what you would do is you would use a serverless data store to write the data out, because containers are meant to be scalable up and down. And if you put your database on a container and storing there, and someone goes to a different identical container, it's got a different database, that is not the way to get a globally consistent replicated data backend. And so you'll see for your App Engine, for homework number 4, I'm not having you write into SQLite 3. You're writing into Cloud Data Store, which is a horizontally scalable serverless backend database. So that's typically the pattern you would see, where that container layer is typically stateless, and then you scale that up and down. It's sort of like a web application sort of thing. And then you would put all the stateful information would be on a backend Cloud Data Store. In this case, Cloud Data Store. So for this, you just supply the app. You don't have to deal with machines or containers. So if you really didn't like the container labs, you don't have to learn Docker. Right? If you are an App Engine developer, you don't care about containers. You don't need to do Docker run. You don't even need to do a Docker build. This is being abstracted out for you. You just write to the App Engine packages, and then it does the containerization for you. Okay? So that's another serverless mechanism. And again, it's got the same problems as Cloud Run. You have this level of control over scaling. You don't know. There is some, like if you go into the App Engine interface, you can see that you have some knobs that you can change in terms of the kinds of machines that it deploys, but there aren't the kinds of knobs that some people want. You also have vendor lock-in, right? So you are beholden to the environments that the platform as a service provider is hosting for you. And you chose that, right? Because you chose not to deal with the portable layer, which is the container layer. And the other thing that people don't like is that it's a fixed environment that your app has to adapt into. And if you need that kind of Python that crazy Python package, or a certain kind of driver that doesn't come stock in a container image, you're sort of stuck. Okay, so these are examples of the serverless platforms that you'll see out there. Heroku basically, they were basically the folks who started all of this container stuff and platform as a service. Okay, the next thing is a serverless function. And this is a special case of platform as a service where the infrastructure is brought up to execute a single function. And with serverless functions, they definitely try and restrict your runtime. They want to make sure that you are beholden to one of several fixed runtimes. And the reason is they want the fast startup. They want to always be able to have a hot container that's able to process your request, and they can do this with a restricted runtime where they supply you the operating environment. With serverless functions, this really enables what's known as event-driven computing. So you can have these single-purpose functions that are executed in response to an event. And then you don't actually have to manage the resources that you need to implement that function. You just write the code, and then whenever it gets triggered, it'll automatically execute, and you don't have to worry about the rest of it. And so what the way this is actually implemented underneath is on these ephemeral predefined container images is the implementation of serverless functions. And again, it's typically stateless. If you have a container image or a function that needs to write out state to store it persistently, then you would use something like DynamoDB in AWS or Cloud Data Store in Google Cloud, where you're going to store that into a backend to persist. One of the things with serverless functions is that these things have a 5-minute maximum in their execution time. So you don't want long-lived jobs to be running on a serverless function backend. Okay, so some examples of this is the Lambda, AWS Lambda, Azure functions, and then this is the icon for Cloud Functions. Okay, so how do you choose between all of these serverless models? Here are some articles that talk about the different trade-offs involved in these platforms. I've tried to summarize some of those just now. But one way to choose is based on the abstraction level of your application. If your application is handling just events, then you would just need Cloud Functions, if it's an event-driven app. If it's handling sort of like a full app, like the code for a full app, then maybe you would do the App Engine. If you have apps that need low-level access to the resources, then perhaps you're in Container Engine. If you have any kind of custom sort of CPU, memory, that kind of requirement, then you're basically down in Compute Engine. So this is one way to choose based on the abstraction level that your application needs to think about. Another abstraction, the other way to choose is the technical requirements. So if you can use vanilla runtime environments, you would use a Cloud Function. If you need some customization, then maybe you would go down to either App Engine allows you a little bit of customization in the packages that you install. But if you need even more, then you're in Container Engine. I can actually deploy a custom operating system and container or and packages in a container. But if I actually need access to like specific GPUs, specific kernels, this sort of thing, a special operating system, then I'm down to the Compute Engine level. So that's another way of deciding where you're going to operate in the cloud. And then this is a big one, your employee expertise. So if you're Snapchat, you have no choice. You don't have an IT networking and an ops person. So you're stuck writing your application code. But if you have a bunch of expertise in the containers and the virtual machines, well, then maybe you can point those employee resources into optimizing your runtime to save you money. Because there is a cost associated with doing one of these higher end services, so you are paying extra for the services that they provide. Okay. So with that, I think I'm going to stop here. Are there any questions? So if you can get started on the labs, I didn't go through any of them, but like the compute, the storage, and then the security labs, you should be able to do right now, just to get a head start. All right.